Here we're asked to multiply three imaginary numbers. You're going to use the imaginary number I, which stands for a square root of -1. First, I'm going to break up each of these radicals into two parts. So the -6 gets broken up into two parts, the -3 gets broken up into two parts, and the -5 can be broken up into two parts as well, with multiplication between all of them. I'll turn -6 into a 6 and a -1 being multiplied together. And the -3 can turn into a 3 times -1. -5 will be 5 times -1. So in each case, I brought the negative out of the original radical and put it under its own radical. I did this because I can now replace the square root of -1s with i's. So this is going to become I radical 6 times I radical 3 times I radical 5. The i's are alike, so they can be multiplied together here, creating I to the power of 3. That's 3 i's being multiplied together. And when it comes to the square root part, we can combine them under one radical now. So we're going to get I to the third times a square root of 90. Now, in order to determine what I to the third is, we could first examine what I was. I was a square root of -1. So I squared becomes a square root of -1 squared. The square root and the square cancel off. So I squared is actually -1. In order to figure out what I to the third is, we could break it up into an I squared times an I. Using our previous results, if I squared can be replaced with a -1, then that would make this -1 times I. Or in other words, just -I. So I'm going to replace that now with -I. Apparently -I and I to the third are the same. When it comes to the 90, I'd like to break him up into a perfect square part and a non-perfect part. If there's any perfect square inside 90, it should go here in this radical, and then anything that's left over, that could go on the right. So I'll do a little tree for 90 to see what's inside him. He breaks up into 9 and 10, where I know that 9 is a perfect square. It's made up of 3 times 3. 10 is not a perfect square. The paired 3's will now go on the left, and you could just represent them as 9, that's fine. If you want to put them in separately, you can, or you could just use a 9 there. The 2 and the 5 have to stay on the right because they're unpaired. So this is going to become -I times the square root of 9, which is 3, times radical 10. And just to simplify my final answer, I'll make it -3i radical 10.